minus log base n to the power of b. Anytime you are having two log subtracted by the minus and the divide, let's say, once you know what I'm doing, what you can talk. Now, log to base m to the power of what? 1 is equal to 7. Anytime you're having log with the power of 1, you don't need to bother yourself, it's 0. Now, log to base m to the power of m is equal to what? 1. Whenever the base and the power, this is the base of the logarithm, and the power are the same, is equal to 1. Then we have what? Log to base what? n to the power of a raised by n. Now, we have a base to the log to base m, the power of a, and to the power of n. That means the power is carrying another power. So what do we have? We would have n log to base n to the power of what? A. So that means, what do you notice? The power will what? Move to the back. Abina, to multiply the logarithm. Now, log to base what? Let's say a raised by b and to the power of c, for example. Now, do you see that the base here is not carrying what? Power. Yes, it's carrying an exponent here. Now, if this b has to go to the back, it will go as inverse. What is b? The inverse of b over 1. 1 over b, abi? Yes, that's exactly. So 1 over b log to base a to the power of c. Then lastly, log to base a to the power of b. Do you know we can write it as what? Log b divided by log a. That means this one can form the log power, another power of a logarithm at the denominator. Then this one will form another power of a logarithm. What if you see a log like this? What does that mean? It means log to base 10, abi? Yes. If I give you log 3, what does that mean? Log to base 10, abi now? So log to base 10. But most of the times, it's better you write it there. So you have introduced another logarithm. For example, if I give you log to base 2 to the power of 3, somebody can write it as log what? 3 all over log 2. It's same thing. It's correct. So that is what you are going to have there. Now, you can write quickly. You can write quickly. Quickly. You can write quickly. So don't forget, when you are adding two logarithms together, you have the same base. You take one base and multiply the powers. If you have a logarithm that have the same base and subtracting each other, that means the power will be divided. The first power divided by the second power, which some person will take as what? Some textbook will take it as what? Log to base n to the power of a divided by b. It's still correct. You see the same thing anyhow you want to write it. Then whenever the powers are what? When the power is carrying a what? A unit value. Unit value means 1. No, log to base m to the power of 1. Log to base 10 to the power of 1. Log to base 100 to the power of 1. It will be what? 0. But whenever the base and the power are the same, it will be equal to what? 1. So this is the basic knowledge you need to know about what? Logarithm. Now, the inverse, which is not too common, but I will just drop it as a bomb for you to understand. Now, if I want to interchange the base to become power, what do we have, class? The base to become power, it becomes what? 1 over log to base. That means b what to the power of what? A. That means you have interchanged. I mean, so what you are going to do as a student of mathematics is to master this. Nobody will help you. You have to master it. Once you master it, you see that I'm teaching without what? Without any book now, because I have it on my head. So I have it what? Cramped. I have it stayed there. So anytime I need it, I will just bring it out. So you don't need to stress yourself too much. Rather to what? You just go through the laws, master the laws, and you are going to apply it neatly. So these are the things that you need to know about the laws of logarithm. So now we want to take a question or two about logarithm questions. Take a question or two about logarithm questions. Now, we are going to solve problem now. We want to see if you are giving log what? 2 equal to what? 0.3010. And log what? 5 is equals to what? 0.6989. See, evaluate log what? 50. Don't forget this base 10, base 10. I mean, base 10, even though they did not put it there, just take it as, though it can be natural base, which is exponential. But for your level, let's take it as base 10. So if I evaluate what? And evaluate this. 0.02. Want to evaluate those two quickly. Let's do those two quickly without using table. They will tell you without using table. So you might see something similar, but you understand now, the same, not the same thing, but if you can understand the method, even in past question, you have a lot of them in past question. You understand me? So now, what you're going to do now is that I want to use normal secondary school to break down this 50 for you. Primary school knowledge. How do you break down 50 without thinking? You know, sometimes they'll say, think of 2 numbers or 3 numbers. I don't want you to think. Don't stress your brain too much. What you're going to do now is to do what? You did this in what? Factors theorem in primary what? Primary 3 or 4. So use 2. How many 2 can go in what? 50. So you want to make 25, Abi? 2 can 2 go in 5? 1 5, Abi now. 5, yeah, what? I mean 5, 25 divided by 5 will give us 5, Abi. Then 5 again. 5 divided by 5 will give us what? You see now? So that means our 50 now, this one can be log to base 10 to the power of 50 can be written as what? Log to base 10 to the power of what? 2 times what? 5 times what? Because 2 times 5 times 5 is 50. I mean now? So you see now, I'm teaching you like somebody that don't know maths before. So we are breaking it down. So if they give you any number, just use this long factors method, break it down one after the other. Your examiner, then you get your value stated. Now, when you do that, what is it? Now we're going to write this as what? Log to base 10 to the power of 2, Abi. Why? Plus. Why am I using plus? Because it's multiplication now. You know, all the power, all the thing now. Just like when you are giving log to base A to the power of what? C times D times E. All of them, if you are giving like that, it's just for you to what? Say log to base A to the power of C plus log to base A to the power of what? D plus log to base A to the power of what? E. I mean now, you just be writing it like that continuously now. Why? Why am I plusing? Because they are what? Multiplying, Abila. So this one now will now give us what? Log to base what? 10 to the power of 5 plus log to base 10 to the power of what? 5. Abila. So I would have what? 0. What is log to base 10 to the power of 2? Is that? Then what is this one now? 0.689 plus what? 0.6. So what do you have now? So you now add it together. You press your calculator. You have your final answer. So 0.3010 plus what? 0.6989 plus 0.6989. So that will give us about 1.6988. You can confirm it. So that you not stay idle. Just occupy yourself with something. So if you press your calculator, that's what you are going to have as your final answer for that question 1. Let's do question 2. You know, we have 2 questions there. 1 and what? And 2. So the number 2 now says what? 0.02. 0.02. That is number 2 question. So write fast so that we can take down something. So you have written all the topic we are going to do. So I can clean it. I can wipe the topic off. And then you tell me one after the other. Once we get to number 2, you tell me number 2. So